Although much of this course has been about arithmetic up to this point, it's very important that we have some sense of what it means to graph an object in the coordinate plane, or what some people might call the two-dimensional plane or the XY plane. So the goal of this lesson is to spend some time talking about some basics related to graphing in the XY plane. Now, before we jump into our examples in a few moments, let me make one quick suggestion here. Some of you might find it beneficial to get some graph paper or some grid paper ready for you as we're walking through these examples. If you want to pause the lesson now to get some graph paper, please feel free to do so. Now let me start by sharing a bit of history about graphing in the XY plane and also share a number of vocabulary terms we will use throughout this lesson. First, let's look at some history. The XY plane, which is sometimes called the Cartesian plane or the Cartesian coordinate system, is named for the French mathematician and philosopher René Descartes, who was born in 1596 and died in 1650. One of Descartes' major contributions to mathematics was his desire to unite algebra and geometry, to try to visualize algebra. And with this in mind, the Cartesian plane, or the XY plane, emerged. And it served as an extremely important tool for those folks who were developing the calculus at the time. People like Newton and Leibniz, who completed their work in the latter part of the 17th century. So, what is this Cartesian plane, or the XY plane? Well, it's the plane or two-dimensional object formed by two number lines. One of those number lines is drawn in a horizontal fashion, and the other one is drawn in a vertical fashion, so that the two lines actually intersect at right angles. The horizontal number line, or the horizontal axis as it's often called, is known as the x-axis. And the vertical axis is called the y-axis. These axes intersect at the point that we call the origin. If you will, everything starts right at that point in the middle. And those two axes divide the Cartesian plane into four sections that we call the quadrants. So up to this point, we've already seen several vocabulary terms: the x-axis, the y-axis, the origin, the XY plane itself, and of course these four quadrants. Now, as a standard practice, these quadrants are labeled in the following way. First of all, quadrant 1 is in the upper right-hand section of the XY plane. Then quadrant 2 is in the upper left section of the XY plane, or the Cartesian plane. Quadrant 3 then is in the lower left section, and quadrant 4 is in the lower right section. So if you can remember where quadrant 1 starts, in the upper right, and then work your way in this counterclockwise fashion, you'll be good to go. Now, that's the skeleton, or the beginning, if you will, of the Cartesian plane. And believe it or not, all of those vocabulary terms that I just shared with you are very standard. So it's important that you know what they mean as you go forward in your mathematical studies. You'll see those kinds of words over and over again as you pick up different books or resources on two-dimensional geometry or two-dimensional graphing. Now, from here, the natural question to ask is this: how do we then label all of the points that are in the plane? I hope you realize that what I shared with you about these axes and so on provided this skeleton, but all of the other area, if you will, the other pieces of that Cartesian plane is filled with points. And so I'd like to know now, how do I identify or label a specific point or location in the plane? Well, here's a little more terminology that will help us with that exact question. Each point in the plane is identified by two coordinates, and those coordinates are the x-coordinate and the y-coordinate. Now together, these two numbers form what we call an ordered pair of numbers, with the x-coordinate always written in the first position and the y-coordinate always written in the second position in the ordered pair. So, for example, the ordered pair 3, 6 has x-coordinate 3 and y-coordinate 6. There's never any confusion. That first number, in this case 3, is the x-coordinate, and the second number, again in this case 6, is the y-coordinate. But how exactly do I know then which point or location in the plane is identified by this specific ordered pair? Well, here's exactly how I figure that sort of thing out. The x-coordinate tells us how far to move horizontally to find our point. Remember, the horizontal axis is known as the x-axis. So the x-coordinate is going to tell me how far I need to move horizontally from that origin point, which is the point where the two axes intersect. If the x-coordinate is positive, then I'm going to move that many units to the right of the origin. And if the x-coordinate is a negative number, then I'm going to move that many units to the left of the origin. This is exactly what we do with the usual number line that we discussed in an earlier lesson when we talked about adding and subtracting positive and negative numbers from one another. So again, the x-coordinates go to the right when positive, and they go to the left of the origin when negative. Now, what about the y-coordinate? Well, if the y-coordinate, that's the second number in my ordered pair, if that y-coordinate is positive, then I'm going to move up the vertical axis from the origin, and I'm going to do so that many units, however many units the y-coordinate states. If the y-coordinate is negative, then I'm going to start at the origin and move down that vertical axis that many units if that y-coordinate is negative. So now, let's try plotting a point in the xy plane just to see what this looks like. Let's plot the point 7, 3. Now I know from what we've already said that the x-coordinate in this point is 7 and the y-coordinate is 3. That 7 tells me that I want to move horizontally 7 units to the right of the origin. So I start at the origin and I march across the x-axis 7 units to the right. From that location, I then move 3 units upward because the 3 is a positive number, and then I want to go up in the y direction 3 units. And that means that the point that is being identified by this ordered pair 7, 3 is located in quadrant 1, and it's easily plotted at this point. It's 7 units to the right of the origin and then 3 units up. Now, I'd like to suggest that we plot a few more points just to get practice with how to use the information that's being shared with us in one of these ordered pairs. So let's look at the following example. Let's plot the point 3, -2. And let me suggest that you plot this one yourself first just to see how you do. Okay, we start here with the x-coordinate. I think it's always wise to start with the x-coordinate here. That is a positive 3. Since it's positive, I start at the origin and I move to the right on the x-axis 3 units. Next, I look at that y-coordinate, which in this case is -2. Since it's a negative number, I move downwards 2 units in the xy plane. And that means that this point is going to land in quadrant 4, as we can see from the image on the screen. And so that point doesn't end up in quadrant 1, it ends up in quadrant 4 because its y-coordinate was negative. Okay, let's plot another point. How about we plot the point -2, -6. And again, let me suggest that you plot this one and then come back and we'll see how you did. Since that x-coordinate is negative, it's a -2, I'm going to start this problem of plotting this point by going from the origin 2 units to the left. And then from there, I'm going to march 6 units. Is it up or is it down? It's down in this case because the -6 is a negative number. And so I move down 6 units from that location in order to arrive at the point that I wanted. And so I see here that this point, -2, -6, is in a totally new quadrant. It's in quadrant 3, right? Now, of course, individual points aren't the only thing that I want to be able to plot in the XY plane. For example, it would be really nice to plot straight lines in the XY plane. And let me ask you this question. How many points do I need to have plotted on a piece of paper in order to give me a unique straight line? Well, the answer to that very important question is exactly 2 points. So I'd like to look now at a couple of examples that illustrate how we can draw line segments in the XY plane if someone gives us 2 points. Let's look at the following example. Let's plot the line which travels through the points 1, 2 and 4, 8. Well, this problem is really just like the problems that we just did a moment ago. I need to plot each of these points separately. I'm going to do it on the same set of axes though, and then I'll just connect the dots. So let's first plot 1, 2. Well, this is the point which is 1 unit to the right of the origin and then 2 units up. And so it lands in quadrant 1 and it can be plotted pretty quickly. By the way, when you do that kind of plotting, let me suggest when you're plotting multiple points on the same set of axes that you actually draw in the dot and then label it. Actually write 1, 2 next to it if you'd like. Next, the point 4, 8, that was the other point that I gave you at the beginning of this example, is also in quadrant 1. It's a bit further from the origin though than the point 1, 2. It lies 4 units to the right of the origin and then 8 units above. And that means that we can plot it, but it's going to be farther away from the origin than 1, 2. Now, once my 2 points are plotted and I've got my little dots drawn in, with a ruler or some other straight edge, you know, the edge of a book or something like that, we simply connect the dots and we have our straight line. And once you have 2 different dots, and they have to be different, but once you have 2 different points or dots drawn on the page, you have a unique line segment that will go through those 2 points. And so you can actually draw either the segment, which is going to just connect the 2 points themselves, or you can draw the infinite line that actually goes through both of the points and, if you will, actually goes off the page to try to show that you actually have an infinite line in both directions. In this case, I'm not really worried about whether we just draw the little line segment that connects those 2 dots only or goes all the way through the 2 dots to emphasize the full straight line. Either way, we'd be fine. Now, I should point out that if we were in an Algebra 1 course, we would probably try to find the equation of this line. For now, we're not going to worry about such a thing. But I do want you to notice a very important fact about this particular line. Notice that as you read over the line from left to right, the line goes upwards. This is very important when we're thinking about something called the slope of a line. And I'm going to talk more about that later on in this lesson. But keep something in mind. As you read that line from left to right, and as the line travels in an upward direction from left to right, remember, it's going to continue traveling in that direction forever. Straight lines don't change direction, if you will, and get curvy. They just go straight and always in the same direction from the direction they started in, if you will. So that slope is a very important item when we're studying straight lines. Now, let's look at a second example of drawing a straight line that goes between 2 points, just for the practice of being able to do these kinds of things. I'd like us to sketch the graph of the line that goes through the point -4, 6 and the point 2, 0. Let me suggest that you pause the lesson at this point, if you'd like, and try plotting those 2 points and then drawing the straight line between them. Okay, now this problem starts out the same way as the previous one. First, we draw our pair of axes, and next we plot the point -4, 6. Now the negative 4 tells us to go 4 units to the left of the origin. Remember that first coordinate is always telling you to either go left or right. In this case, it's a negative 4, so we go 4 units to the left of the origin. And then the 6 tells us to go up 6 units from there because it's a positive 6. If it had been a negative 6, we would have gone down 6 units from there. So that point, negative 4 comma 6, is pretty easily plotted. And do you see which quadrant it's in? It's in quadrant 2. Okay. Next, we need to draw the point 2 comma 0. Well, the 2 is the x-coordinate in this case. That tells me to go 2 units to the right of the origin. No problem there. Now, what does the 0 tell us in this point? Well, that 0 is in the y-coordinate, or it is the y-coordinate, it's in the y position. But what does it mean to have to go up or down 0 units? That can be a little bit confusing. Well, what it means is don't go up and don't go down at all. So the point here, 2 comma 0, is just going to sit right on the x-axis 2 units away from the origin. That is the correct position or the correct location of the point 2 comma 0. It's right on the axis. And that's kind of an interesting twist to these kinds of problems, but it's nothing scary to worry about. One other comment I'll make about that point is that it's actually not in any particular quadrant. It's sort of lying on the boundary between 2 of the quadrants, in this case quadrant 1 and quadrant 4, but ultimately it's not in either quadrant. It's lying right on the x-axis in this case. Now, we can just draw the straight line that connects these 2 points and we're done. We have our 2 points plotted, we take out a straight edge, we draw that straight line, and it turns out that we're finished. Now, I want you to notice how different this line is compared to the earlier line that we drew a few moments ago. Do you see that as we read this line from left to right, the line is actually going downward now instead of upward? That makes this line very different from the other one that we drew in a previous example. And the thing that measures this difference in terms of going up or down is this thing that we call slope. Now, I've mentioned slope a couple times in this lesson, so I'd like to suggest that at this point we talk about what this slope really means. Now, think about when you've heard people talk about slope, used the word slope in real life. One of the first things that comes to my mind is a ski slope. And what does that normally refer to? Well, it usually refers to the natural incline of the ground on the side of a hill or a mountain. And that certainly gives us a visual idea of what is going on with these lines. The side of a hill or a mountain can be thought of as a straight line, although I realize that's a bit of a stretch because the natural terrain of a hill or a mountain is usually kind of jagged, or it's usually rolling or something like that. But in an ideal world, from a mathematician's point of view, I can think of the side of a mountain or the side of a hill just as a straight line. And with that idea of a ski slope in mind then, let me give you a working definition for slope that we're going to use in this lesson. The definition is this: the slope of a straight line that goes through the 2 points x1, y1 and x2, y2 is given by the quantity y2 minus y1 all divided by x2 minus x1. And what is that? Well, actually, if you want to think about it for a moment this way, that quantity, that fraction, is the same as the vertical change in the y values divided by the horizontal change in the x values. Now, some people like to say that the slope is the rise over the run of the line, where the rise refers to the amount of vertical change and the run refers to the amount of horizontal change. Now, others will say that the slope is the change in y over the change in x. However you remember this idea of slope, it's important that you see that slope is basically just a fraction. It's just a ratio, and we've been studying those throughout this course. So you should be very comfortable once we've practiced with calculating a few of these, because basically the slope is just a fraction. Now, this quantity, slope, then measures exactly how steep or how flat a straight line is, because it's measuring how fast the vertical amount is changing as the horizontal amount changes. So a steep hillside will have a very large slope because the vertical or y values are changing very quickly as the horizontal values change. A road on a really flat surface will have a very small slope if you think about it as a straight line, because the vertical distances aren't changing that much as you travel along in the horizontal direction. Now, with this definition in mind, let's calculate the slopes of two line segments, exactly the two line segments that we've drawn earlier in this lesson. The first line segment went through the 2 points 1, 2, and 4, 8. How do we calculate the slope of the line that goes through those 2 points? Well, it's actually not that hard. The slope is equal to the change in y divided by the change in x. Okay, what is that? Well, the change in y is 8 minus 2. Notice that that's the two y coordinates subtracted from one another, 8 minus 2. And we then divide that by 4 minus 1. And again, the 4 minus 1 is the difference of, or the subtraction that we would do between the two x coordinates. And it's very important that I point something out here. When I do 8 minus 2 divided by 4 minus 1, I have to make sure that I subtract the two y coordinates and then the two x coordinates that correspond. I have to not twist them, if you will, and write 8 minus 2 divided by 1 minus 4. We'll talk about that more in just a moment. Now let's simplify this just a bit. Well, 8 minus 2 is going to give me 6, and 4 minus 1 gives me 3, and 6 divided by 3 is equal to 2. So the slope of that line that we drew several moments ago is 2, and I want you to notice that it is positive 2. And here's a very important fact about slopes related to lines. Anytime you have a straight line that goes upwards as you read it from left to right, that line will always have a positive slope. If I had told you that the slope of that line was negative, we would know I was wrong, because anytime your line is going upward as you read it from left to right, the slope must always be positive. Now, let's look at the slope of that second line that we drew a few minutes ago. It went through the points -4, 6 and 2, 0. So its slope looks like the following. I'm going to take the fraction 0 minus 6, that's the difference in the two y values, the two y coordinates, and I'm then going to divide that by 2 minus a -4. Again, I took the y coordinate of 0 and then the other y coordinate of 6, and then I divided by their corresponding x coordinates, the 2 minus the -4. When I do that, I have 0 minus 6, which is -6. We learned how to do that in an earlier lesson of this course. And the denominator becomes 2 minus a -4, which is the same as 2 plus 4, and that's equal to positive 6. Again, we learned just a few lessons ago how we would calculate something like 2 minus a -4. And that means now that my slope fraction is -6 divided by 6. And that's equal to -1. Remember, when you divide two numbers, one of which is negative and the other one is positive, you know that your final answer has to be negative. We talked about that earlier in this course as well. Now, this line's slope is negative. It's equal to -1. And that negativity will always be true when the line goes downward as you read it from left to right. So this is very interesting. The slope itself, that number, encodes for us whether the line that the slope corresponds to is either going up or down. It actually allows you to interpret something about the line itself by looking at that numerical value. In fact, one of the motivations for developing calculus itself was to find the slope of a tangent line for lots of different kinds of graphs. And so this slope has been historically important. This idea of finding the slope has been very important for hundreds of years. Now, before we close this lesson on graphing in the Cartesian plane, I'd like to talk about one other concept with you about straight lines in particular. And this idea is the idea of the midpoint of a line segment. Now, sometimes we really want to know where the middle part, or the midpoint, if you will, of a line segment is. But it might seem kind of hard to find. Honestly, it's not hard to find as long as you remember the formulas that you need to find the midpoint of a line segment. So let's find the midpoints of these two line segments that we've been working with throughout this lesson. First, we had that line segment that connects the point 1, 2 and 4, 8. Now, how do we find its midpoint? Well, it's not a problem. Let me talk you through it. The x-coordinates of the two original points are used to find the x-coordinate of the midpoint. And the y-coordinates of the two original points are used to find the y-coordinate of the midpoint. And the formula in this particular case looks something like this. The x-coordinate is going to be 1 plus 4 all divided by 2, and the y-coordinate is going to be 2 plus 8 all divided by 2. Now, where did the 1 and the 4 and the 2 and the 8 come from? The 1 and the 4 are the two x-coordinates of the original points, and the 2 and the 8 are the two y-coordinates of the original points. So all I did was add the two x-coordinates and divide by 2. That's the new x-coordinate for the midpoint. And I added the 2 plus 8, which were the two y-coordinates, and divided by 2 again. And when I do the arithmetic there, that means I have 5 halves for the x-coordinate and 10 halves for the y-coordinate. And if you simplify those a little bit, you'll see that the midpoint then has coordinates 2.5, or 5 halves, comma 5. 10 divided by 2 is just 5. Now notice how our work on fractions several lessons ago came in really handy there. We can actually plot this point now and see if we're really correct. So if you still have your drawing of that line segment on the graph paper, go ahead and plot this point now and see if we got the right midpoint. Well, it looks like it's on the line. That's important. The midpoint needs to be a point on the line, and it does appear to be right in between the two endpoints. And that means we've got the right midpoint. Now, let's practice a bit more by finding the midpoint of the other line segment that we drew a few moments ago. We connected the points -4, 6 and 2, 0. So we know the midpoint here is going to be the following. -4 plus 2, all divided by 2, and then 6 plus 0, all divided by 2 as well. Those are the two coordinates for the midpoint. Now let's simplify these two fractions again. -4 plus 2 is equal to -2. So the x-coordinate of the midpoint is -2 divided by 2. And the y-coordinate of the midpoint is just going to be 6 over 2 because 6 is 6 plus 0. And now if I simplify those two fractions just a bit, it looks like my midpoint is at the coordinates -1, 3. Now I'm going to suggest you plot that point to see if it really is the midpoint of our line. And if we've done everything correctly, then we're good to go. Notice that that point has to be on the line, and if we've drawn it correctly, it is, and it seems to cut the line into two equal-sized pieces. Cut the line segment, I should say, into two equal-sized pieces, and it does. Now, you might be wondering, why did I keep dividing by 2 in the coordinates of that midpoint? Did you notice? In both of those examples, I kept dividing everything by 2 everywhere. Well, to be honest with you, what we're doing when we add the two x-coordinates and divide by 2 is we're finding the average of the two x-coordinates. And then we're also finding the average of the two y-coordinates of the original points. So if you think about it for a moment, that should give us the midpoint, because we're really basically doing averages in order to find the coordinates of that point. Now, in this lesson, we've learned a lot of new terminology related to plotting points in the xy plane or the Cartesian plane. We've also talked a bit about the slope of a straight line and the midpoint of a line segment. There's lots in this lesson that you'll want to digest before we move on to our next lesson, which will be about some basics in two-dimensional geometry.